Getting to Mars has historically meant waiting for perfect planetary alignment, but the ESCAPADE mission is different. We're setting a new course, rethinking the way we access the red planet.
So to get from Earth to Mars, we turn on an engine, and what that does is expels mass out of the back of the spacecraft and pushes the spacecraft forward. And the net effect of a maneuver is to increase our velocity. And so you often measure a maneuver by the amount of change in velocity that it executes. Now, there are two aspects to changing your velocity. One is that you're changing the amount of the velocity, so the speed you're going at. The other parameter that you change is the direction.
Ideally, we burn hard and head straight for Mars. But we launched out of phase, so the direct path is closed. We have to utilize a Lagrange point to store our energy.
We have launched out of phase, basically almost 1 year opposite from where you should. But the orbiting around these Lagrangian points is a really low energy spot to kind of hang out. It is a point in space that's about 1.5 million kilometers away from Earth.
This isn't downtime. Loitering is a complex operational state. We are millions of kilometers from home in a gravitational balancing act.
We still have course correction maneuvers to go. So we've got 15 of those course corrections to go over the course of the next year as we kind of loiter around this Lagrangian point.
Once we've executed the first trajectory correction maneuver, we'll be looking at a lot of the data generated by the spacecraft. The second trajectory correction maneuver is a longer burn. It's about 200 seconds long. That one puts us on the loiter orbit. For the first 12 months of the mission, the furthest we will go is about 3.3 million kilometers away. And so for the first 11 months of the mission, we're in a loiter orbit where we are leaving Earth and progressing towards one of the Lagrange points, which is a stable point in the Earth-Sun system.
We hold this pattern for a year until November 2026. That is when the physics finally line up. The wait ends and the real risk begins.
The planets will be aligned again in November of 2026, and that's when we will execute one of our biggest burns, the trans-Mars injection, which is going to take us to Mars.
The one definitely that is going to be the most spicy will be the trans-Mars injection burn. There's a really small window where you have to make that maneuver. So you've got to reorient the vehicle in a certain direction. You've got to prime the engine just before that. And you've got to hit that window, otherwise you're not going to Mars. That will be the tricky one for sure.
This is the reality of interplanetary operations. It's not just about the launch, it's about the endurance to navigate the void and the precision to hit the target.
But once we make it through the Mars orbit insertion and are in Martian orbit, then we'll have demonstrated that we can do these very complex missions for a third of the time and a 20th of the typical cost.
When a lot of people decide to be aerospace engineers one day, it's because of dreams like this.